Okay, so welcome to this tutorial. So here we'll be concentrating on the first question in the assignment given by Mr. Chishala. So we'll be doing subnetting. Okay, so uh, in the first part, as you can see, it's saying what is the block size, the address, network address, the range of valid IP addresses to which the IP address this belongs. So show your working clearly. So the first thing, we need to analyze the IP address itself. 192.168.5.30 and then /29. So this is the IP address which we are given. So this is the IP address ending at .30. Then this is the mask which is given. So in this case, we need to identify where does this IP address belong. So this IP address belongs to class C. So if it's a class C, it means this portion up to here is the network address. So that part is the network portion. So say network portion. So that's the network portion. So the network portion will never change. Then the host portion, which is .13. So this host portion will be always changing based on the number of hosts we want to accommodate. Then this slash just represents the number of ones in a network. So in this case, we have 29 ones in a network, which is representing a subnet mask. So for us to further understand this, I'll come up with a very same table and explain further. So a very same table will be created. So a very same table, this is just variable length subnet mask. So there are two types of subnetting. We have static subnetting, which is classful subnetting. So in classful subnetting, we don't change the block size when coming up with the number of subnets. But under variable length subnet mask, or let me say dynamic subnetting, which is known as classless subnetting, we keep on changing the block size when coming up with the number of subnets. So in summary, we can say for static subnetting, we change the slash, which is this, to know the number of hosts we can accommodate. Then for classless, which is very same, we keep on changing that slash for us to accommodate something. So in static, we don't change. Then very same, we do change. Okay. So a very same table starts with the block size. So a block size, and then CIDR, which is for classless interdomain routing. Then now we go to the subnet mask. So I'll be explaining these terms one by one. So a block size starts at 1, then CIDR will just start at 32, but that's not the initial. I'll explain. Then the subnet mask is 255.255.255.255. Now let me explain from here. So block size is just a value which tells us how many devices or IP addresses we can accommodate. So in this case, let me give an example. If the block size is 128, so if the block size is 128, it means 128 can accommodate a certain number of devices. So that's the size which can accommodate the number of IP address we want. Okay, so coming to the CIDR, which is class-less interdomain routing. So we said these are the number of ones in a network. So since we have 32 ones, I'll just say 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. So now if you can see, we have four portions. We have 1 2 3 and 4. So these four portions have 8 bits. So 8 times 4, 32 ones in a network. So because it's a class C, this part will never change. So it means this is the network portion ending to there, and then this is the host portion. So same applies to this. This is the network portion, this is the host portion. So this is just a binary representation of a subnet mask. So for us to confirm, let's convert this number into binary. So let's do that. So binary is base 2. Then we need to know the target, which is 255, then the remainder. So I'll open up my calculator. Okay. So our target is 255. If we divide it by 2, we get, so if we divide it by 2, we get 127, but 0.5, so the remainder is 1. Again, if we divide 127 by 2, we get 63, but the remainder is 1 because it's 0.5. Again, when we divide 63 by 2, divide by 2, we get 31.5, so the remainder is 1. When you divide it by 31, we get 15, so the remainder is 1. We divide it by 15, we get 7, the remainder is 1. We divide by 7, we get 3, the remainder is 1. We divide by 2, by 3, we get 1, the remainder is 1. Then if we divide by 1, it's 0, the remainder is 1. Okay, so if we count the number of binaries starting from the bottom, you realize that there are 8. 1 2 3 4 5 6 7 8. So if we continue even changing these other values, there will be 8 ones. So this is the meaning. Okay, so now that we do understand what's happening, we can now proceed to finishing up this VSM table. So under the block size, we'll be saying times 2 to come up with the block size. Then the CIDR will be saying minus 1 to come up with the CIDR. So the block size 1 times 2, we are getting 2. And then 31 minus 1, or 32 minus 1, which is 31. And then for the subnet, since we said this part won't be changing, so even that part won't be changing, but I'll be changing the host portion. So in this case, we'll say 255 minus 1, which is 254. Then again we proceed 2 times 2, which is 4. And then 31 minus 1, which is 13. Then the portion which is changing, again we say 254 minus 2, which is 252. And then 4 times 2, which is 8. 30 minus 1, 29. So let's check again. So we have 252 minus 4, which is 248. So 8 times 2, 16. And then 29 minus 1, which is 28. Then again, this portion we'll say 248 minus 8, which is 240. Okay, and then 16 times 2, which is 32. So 28 minus 1, which is 27. And then let's say 240 minus 16, which is 224. And then 32 times 2, which is 64. 27 minus 1, which is 26. And then we have this part. So 224 minus 32, which is 192. Okay. So 64 times 2, which is 128. 26 minus 1, which is 25. Now we have this portion. So 192 minus 64, which is 128. Okay, now after you reach 128, under the block size, you just put a 0. Now 25 minus 1, we have 24. And then this portion, we have 128 minus 128, which is a 0. Now, when you're given an IP address from the internet service provider, this is the initial start of a Class C network address. So in this case, the default subnet mask is this, then the slash is this, okay, and the block size is 0. So meaning if we are given this IP address, which was this, okay, let me copy it. We get an IP address from the internet service provider. Let me say it's this. So since we are saying it needs to be a /24, which is the initial, so this, since this portion is the host portion, it needs to start at 0. If you haven't assigned any device, then this will be a /24, because that's when we are starting like this. So that's the meaning. So if we get an IP address from the ISP, internet service provider, they'll give us something like this. Okay, so now I'm sure you are able to see what's happening. So in this case, the network address, network IP address, which we are given from the internet service provider, will say it's this one. Okay, so that's the network IP address which we are given from the internet service provider. Now the question has given us a /29. So where there's a /29, we have a block size of 8. So as I said, a block size of 8 will help us identify the number of hosts we can accommodate. So we say subnet 1, subnet, so say subnet 1. So if subnet 1 is the initial, we'll say what's the, okay, let me just write some information here. So the block size for this network which is needed, block size, it's 8. So now we come to the number of hosts. So for the number of hosts, we'll say since the block size is 8, whenever we are subnetting, we need to subtract the network address and the broadcast address from this block size. So it's more like a block size minus 2 will give us the number of hosts. So in this case, 8 minus 2, it's 6. And then their subnet mask, as we can see, for a /29, we have 248. So that's their mask like that, 248. Now we can start creating the subnets. So subnet 1, the IP address range. So the IP address range, since the initial is this, which is .0, so we'll start like this, 2. Now since our block size is 8, to say 8 plus 0, which is giving us 8. But because we need to have a broadcast address, we say -1 to have a 7. So let me just explain something here. So since a block size will help us know the number of hosts we can accommodate, which is 6. So in this case, I'll say if this is an IP address, we consider it as 1, and we have at least 7 IP addresses here because we have a 7. So the meaning is that 7 minus 1, we have 6 IP addresses in between, which can be assigned to devices. So that's the meaning. So this is the network address, and this is the broadcast address. We were subtracting from 8 to come up with 6 hosts. Okay, so now let's continue. So this is subnet 1, we are done. We come to subnet 2. So subnet 2, since we ended at 7, so just start at 8. So it's more like if you added this 8 plus 0, you are supposed to get 8. That's the meaning. So where are we ending now? So since we are starting at 8, we say 8 plus 8, which is now 16. But to remove a 1 to maintain the broadcast address, which is coming 15. So again, this is the range for this particular subnet 2. So we come to subnet 3. So since we ended at 15, we're going to start at 16. So we say 8 plus 16, I'm sure, which is 24. So instead of saying 24, just put 23 to maintain the broadcast address. Okay, now we got subnet 4. So subnet 4, since we ended at 23, we're going to start at 24. So, but where are we ending? So we say 8 plus 24, which is 32, but we say 31 to maintain the broadcast address. Okay, so we come to subnet 5. By now you know the pattern. So for subnet 5, we are starting at 32 because here we ended at 31. So we have 8 plus 32, which is 40. Now we remove a 1 to become 39. So we can continue doing this process till we reach the maximum subnet. But let's go back to the question. The question is saying the IP address you are given is .30. So it means we need to look for a range which can assign an IP address which is .30. Remember, these are network addresses, then these are broadcast addresses. So can 0 to 7 assign a .30 IP? No. Can 8 to 15 assign .30? No. Can 16 to 23 assign .30? No. Can 24 to 31 assign .30? Yes. So subnet 4 is our target. So I'll copy that and say answer. Okay. So subnet 4 is our target. So remember, they are saying a device, for example, let me say if it's a PC, is assigned with .30, which is 192.168.5.30. Yes, it's possible because a network address cannot be assigned to a device. Then the broadcast address cannot be assigned to a device. But before we reach .31, we can reach .30, meaning it makes sense having this. So it's a /29 because we were using the block size of 8 to come up with those particular subnets, as you can see. So it's a /29. So now that we have identified the thing, let's follow the question. What is the block size? What is the block size? So the block size, as you can see, we'll say the block size is 8 because I'm just from explaining. Okay, so the network address is this. So this is the network address I kept on talking about it. So I'll just say block size. So block size, we know it's 8. Then the network address, I'm just following the format. So that's the network address. Then the range of valid IP addresses to which this IP address belong. So valid IPs, valid IP addresses. So in this case, since we know we cannot assign .24 because it's a network address, it means we can start at 25, then 2. Now, we cannot assign .31 because it's a broadcast address, meaning before that we have .30. So these are the valid IP addresses which we can assign to a particular device on a network. In this case, we chose this IP address based on the question, which is .30, to be assigned to a particular device. So that's all about question 1. So my name is Soko James, representing KMU Cybersecurity Tutorials. I hope you understood, and thank you for watching.